Write down. Determination of specific latent heat of fusion of ice. Determination of specific latent heat of fusion of ice. Determination of specific latent heat of fusion of ice. Determination of specific latent heat of fusion of ice using method of mixtures. Using method of mixtures. Using method of mixtures. Right. Make it lazy. Right. Listen. Abi materials theory explain kan lazy. Write down materials and apparatus. Materials and apparatus. Materials and apparatus. Right? Materials and apparatus. Write down a calorimeter. Don't draw. Write down a calorimeter. A calorimeter. A styrer, comma, thermometer, comma, styrer, thermometer. Styrer can listen. Styrer that is called a square net or net styrer. Right? Make a specialty write it as net styrer. Net styrer. What special net styrer. That is also called square net styrer. Net styrer. Right? Net idea. Net right. Then heat insulated lid. 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 Then sufficient amounts of water and ice. 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 Right? Then triple beam balance. Triple beam, 4 beam or electronic. Triple beam / 4 beam. Right? Make a chemical use karana puluang. Right? Chemical balance kila teka tina dana. Chemical or electronic kone ka puluang. And since we need more accuracy, it's better to go with 4 beam, electronic or chemical. Right. And very importantly, this is a unique one, filter papers. Right now, filter papers. Filter papers. Filter papers. Filter papers. Right. Listen. Label move. Now, this is the insulated cover as before. Right? Insulated cover. All the heat loss from conduction, convection, and radiation should be minimized. Right? Then explain I in detail explain these are insulated supporters. Right? Conduction to minimize conduction. Insulated supports. Right? And insulated lid. Right? Insulated heat insulated. And this is net styrer. Net styrer. Right? Net styrer. Thermometer. Thermometer. Right. Make a calorimeter. 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 Right? It was make a water in fill color water. Right? It was a methana. This is called ice chips. Ice chips. ice chips, right? Ice chips නැත්නම් small pieces කියලා කියනවා. Small pieces, right? Now take down the diagram and label, right? මේකේ theory එක lazy. Take down the diagram and label, right? කරන්නේ කොහොමද කියලා කියන්නම්. Ice chips ආවේ කොහෙන්ද ඒ ටික කියන්නම්. Take down the diagram and label it. I think in one of the recent paper discussions also I discussed this one, right? Ribbon? Ribbon? Okay, finished? Finished? And check labels. Net styrer, calorimeter, insulated cover, right? අර කලින් වගේ තමයි ඒක rigiform වගේ එකක් දාන්න නැත්නම් air itself is also fine, right? cotton දාන්න පුළුවන්, cotton වල වඩා rigiform හොඳයි, right? Rigiform is the best one we have nowadays කියලා කියන්නේ best one we have now with the availability and everything. Insulated support, ice chips, or that is called small pieces of ice chips, නැත්නම් small pieces. Thermometer, insulated lid. හරි? Right. මේවයි කරන්නේ. Listen. So first of all, we have to have an ice cube, right? First of all, we have to have an ice cube, and you have to break it into small pieces. You have to break it into small pieces. Small pieces doesn't mean too small. Small pieces කියලා කියන්නේ that is not too small pieces. මේ chips කිව්වම තේරෙනව නේද? Right? Chips කියලා කියන්නේ පොඩි pieces කියන එකනේ. අර නිකන් powder එකක් වගේ වෙන්න බෑ. ඒ කියන්නේ නිකන් ගොඩාක් පොඩි වුණොත් experiment එක කරන්න බැරි වෙනවා. මම ඒක reasons වලදී කියන්නම් ඉස්සරහට. Right? Because now always we are going to add ice chips, melting ice chips to the system here. Melting ice chips තමයි දාන්න ඕනේ. Right? How to make sure ice chips are melting? Ice chips melt වෙනවා කියලා කොහොමද අපි බලාගන්නේ? Right? When you keep it in atmosphere, right? You should see some formed water. Water form වෙලා තියෙන්න ඕනේ. ඒකනේ melt වෙනවා කියන්නේ. Right? Then that is a verification that your ice cube is not at a negative temperature. නැත්නම් දන්නේ negative තියෙන්නේ කියලා. Right? You have to make sure that it is at zero. Melting ice. Right? Melting ice දැන් melt වෙද්දි around the ice cube දැකලා තියෙනවනේ. Around the ice cube or ice chip, right? We have a small layer of water, right? Ice cube එක melt වෙද්දි layer එකක් එනවනේ water, right? To remove that water layer, we have filter papers here, right? Ice chips ganna, body ice chips, small pieces, and have to remove the water layer around the ice chip by the filter papers, right? Filter papers කියලා කියන්නේ ඒක තියෙන අරක පිහ දාන්න to remove water layer, right? ඒක හොඳට remove කරලා, right? You have to remove it, and then one piece, only one piece at a time, one piece is added to the calorimeter, right? There is an initial amount of water inside the calorimeter, right? Agan, okay, sir. Right? There is an initial amount of water inside the calorimeter, and one ice chip is added at once, right? And when ice is added, what can you say about density of ice and water? What is higher in density? Water, right? So ice floats. When ice floats ice comes to the surface of water, no? Right? If it comes to surface of water, 10% of ice cube is going to be above water. 90% is only immersed, right? If 10% is above water, that is not going to get heat from the water, no? Right? So therefore, you have to make sure that ice chip remains inside water until it is fully melted, right? For that, net styrer is used. Net styrer එකේ තියෙන්නේ මේ styrer එකේ තියෙන net එකක් එක්ක. net එකක් එක කියලා කියන්නේ, have you seen මේක දැකලා තියෙනවද? අර මේ පරණත් නෑ, දැනුත් තියෙනවා. පරණ නෑ, නෑ පරණ නෑ. හරිද? මේ ඉස්සර නෙමෙයි. සමහර ගෙවල් වල ඉස්සර කියන්න බෑ, සමහර ගෙවල් වල තේ හදද්දි දැකලා තියෙනවද මේ if you are not using tea bags, අර I hope you are not using tea bags, අර මෙහෙම එකක් use කරනවා මේ, ඒකට නිකන් තේ ගොට්ට කියලා කියන්නේ ආච්චිලා හැම. ඒක හැබැයි ආච්චිලා වගේ තමයි ටිකක්. ඈ? ගොට්ට. ඈ? What's the term for that? ඒක term එකක් තියෙනවද? term එකක් තියෙනවද? දන්නේ නැහැ මං අහලා. term එකක් තියෙනවද? ඉංග්‍රීසි term එකක් තියෙනවද? ඉංග්‍රීසි term එකක් තියෙනවද? තේ ගොට්ට අහලා තියෙනවද? තේ ගොට්ට දන්නේ නැද්ද? තේ ගොට්ට දන්නවා ඉංග්‍රීසි term එකක් තියෙනවද? මං හිතන්නේ ඒකට ඉංග්‍රීසි term එකක් නැද්ද කොහෙද? Right? Anyone? I haven't heard English term. I haven't come across any English term for this. You have seen this, right? මේක දන්නවනේ. මේකට මේ දන්නවද තේ හදලා තියෙන? මේකට මොනවද දැන්? මේකට අර මේක දාලා, right? මේක උඩින් වතුර දාලා, මෙහෙම කප් එකක් තියලා, මෙහෙම තේ එකක් හදාගන්න දන්නවනේ. මෙන්න මේක තියෙන්නේ, right? Let's say it's තේ ගොට්ට for now. ඒක තේ ගොට්ට තමයි ඉතින් වෙන මන් දන්නේ නැහැ. මොකද කියලා මේකම තමයි මේ තියෙන්නේ. මේ වගේම එකක් තමයි මේ තියෙන්නේ. අර ඒ ගොට්ට shape එක තියෙන්නේ. right? මෙහෙම එකක් තමයි දැන් තියෙන්නේ. right? with the handle මෙහෙම මේකට handle එකක් තියෙනවා. කොහොමද කියන්නේ? right? මේක net එකක්. this is net අරගම තමයි යෝනේ. මේක net එකක් තියෙන්නේ. බලන්න. this is net. Then when the ice chip is inside, listen, when the ice chip is inside, that is going to cover by this net, no? Right? ඔන්න ඕක තමයි මෙයාගේ purpose එක. net styrer. Right? Then if you ask whether a normal styrer can be used, no. එහෙම use කරන්න බෑ. එහෙම වුණොත් ice cube එක උඩට එනවා. Right? ඒකයි net styrer එකක් use කරන්නේ. Now what happens is, right? What happens is this ice cube is going to absorb heat from water, no? And it is going to melt. Ice melts. Ice එක melt වෙනවා. Ice එක melt වෙනවා. Right? So likewise, we will be adding ice pieces one by one, right? One by one, only one at a time. One by one, after removing water from filter papers, you have to add it one by one, and finally, these readings are taken, right? The readings මම මුලින්ම මොකුත් කිව්වේ නැහැ. readings කියලා කියන්නේ මේ ටික. මුලින්ම අර කලින් වගේම තමයි. We need empty calorimeter with styrer, let's say M1. Then after water is filled, then water plus calorimeter styrer, say M2, right? Then initial temperature of water, theta 1, right? Then final mass of system, right? M3, right? Now mass of water is here, no? Mass of water is M2 minus M1. Alright? What is mass of ice added? කොහොමද ඒක ගන්න? M3 minus M2. right? මේ තියෙන්නේ ice add කරන්න කලින්නේ. Then mass of ice මෙතනින් එනවා. Mass of ice mass of ice m3 minus m2, right? Now all heat losses are controlled here, right? Then precautions conduction, convection, radiation are controlled, right? Then we can assume that there's no heat loss to the environment, right? Other than that, we are going to follow method, heat compensation method in this one as well, right? Our temperature difference compensate then only option we got is heat compensation. Right? Then if there's no heat loss to environment, right? Tell me, what is the equation? What is the relationship between ice and water now? Ice is absorbing heat, no? Ice absorbs heat, and first of all, it should be melted, right? Then melted ice is at which temperature? Ice melted what temperature? 0, right? Then it is increasing. It should increase its temperature to the final temperature, right? Ice melts system 0 the system is going to reach the equilibrium in some kind of a temperature somewhere in between, right? Then 25 kila, 0 in 25 are melt pela ice heat right? Okay, now this side is ice. See, heat absorbed by ice equals heat liberates by water plus calorimeter, right? Ice absorbs heat for two things. First one is state change, melting. Ice melt only, melt heat ml. Mass of ice is m3 minus m2. m3 minus m2 into L of ice, right? Right. Then ice melt m3 minus m2. Ice mass of ice is melted, and now it is at 0. If the final temperature of the system is final temperature now finally final mass and final temperature. Final temperature say 0, right? If the final temperature of the system is 0, water forms by ice is initially at 0. It should increase its temperature up to 0, right? It is also absorbing heat. It absorbs initially 0 25 25 final temperature. It absorbs heat. Absorption then same ice amount m3 minus m2 same ice amount absorbs heat CW theta 2 minus 0 until it is reaching the final temperature, right? මේක තමයි ගොඩක් අයට මිස් වෙන්නේ මේ එක්ස්පෙරිමන්ට් එක කරද්දී. ice melt වෙන එක ලියනවා. හැබැයි heat increase එක ලියන්නේ නැහැ. When ice is melted, it is at 0. 0 වල තියෙනක final temperature එකට යන්නත් ඕනේ. Right? Clear? Then from the other side, heat liberates by water and calorimeter. Water කියලා කියන්නේ m2 minus m1, right? Then this water is coming from initial temperature to final temperature, theta 1 minus theta 2, because the system is cooling down, system cools down, ice add kare, system cools down, then it is coming from theta 1 to theta 2. And with the temperature difference theta 1 minus theta 2, theta 1 minus theta 2, and the calorimeter with styrer, right? This ES is also coming from theta 1 to theta 2, right? Menna heat equilibrium thermal equilibrium right? Using this equation, m3, m1, m2, m3, CW, CS are known, right? Which means L can be determined, right? L can be determined, right? Experiment right? Any questions? Right? Explain calling any questions? Explain I have explained everything about the experiment now, right? Special things but everything about the experiment is explained. Any questions before we take this down? All good? Right. Then diagram again. Right. Method Killian. Method. First point. Measure the mass of. Measure the mass of. It is called strainer. Strainer තමයි. Strainer තමයි නේ. හරියයි. That's correct. Good. Strainer. Yes, yes, yes. Double strain කියලා එහෙම අර මේක හරියයි. Strainer තමයි. Term is correct. Strain double strain කියලා term සාල් නැද්ද? ඉමේජ් ආලා තියෙනවා වගේ. ආලා නේ. හරි. Strain තමයි. හරි. Thanks. Right අර මට ඒක strain කියන එක ආවේ නැහැ. මොකද double strain කියන word එක මම double strain අහලා තියෙනවා. Single strain double strain දන්නවා. මේ හැබැයි ඒක tea industry එකේ නෙමෙයිනේ අහලා තියෙන්නේ. ඒකයි. ඒක ඔයගොල්ලෝ අහලා ඇති. මේ බා ඉන්ඩස්ට්‍රි එකේ තියෙන බාවල ඒ කියන්නේ පබ් වල එහෙම ඔය මේ මොනවාද මොක්ටේල්ස් මේ මොක්ටේල්ස් නෙමෙයි කොක්ටේල්ස් මොක්ටේල්ස් ඔය එක එක දන්නවනේ මේ කොක්ටේල්ස් සමහර ඒවා ඩබල් ස්ට්‍රේන් කරලා එහෙම දෙන ඒවා තියෙන අන්න ඒක right ඒක ඩබල් ස්ට්‍රේන් නැත්නම් සිංගල් ස්ට්‍රේන් නැත්නම් ඩබල් ස්ට්‍රේන් හරි කරලා දෙන්න right it's correct good okay thank you. Measure the mass of empty calorimeter plus with stirrer. Measure the mass of empty calorimeter with stirrer. Measure the mass of empty calorimeter plus stirrer. With stirrer. Within brackets M1. Within brackets M1. Right. Next point. Add water up to 2/3 of height අර කලින් වගේම තමයි up to 2/3 of height up to 2/3 of height of calorimeter up to 2/3 of height of calorimeter and measure the mass of water calorimeter with stirrer. Mass of water calorimeter with stirrer within brackets M2 and initial temperature of system right. Next point, add dry ice chips. Dry means it should be water layer should be removed. Dry ice right. Dry ice කියලා කියන්නේ water layer නැති එක හොඳේ. ඒකට තමයි filter papers use කරන්නේ. right. අර අනිත් ඔයගොල්ලෝ දන්න dry ice නෙමෙයි. right. තව එකක් තියෙනවා dry ice කියලා ඔය මේ carbon වලින් එන එක. ඒක නෙමෙයි. right. මේ dry ice කියලා කියන්නේ when the ice cube is dry. right. නැත්නම් අර carbon structure එක නෙමෙයි. right. මොනවද කිව්වේ? Add dry ice chips one by one. Add dry ice chips one by one while well stirring water Next point, stop adding ice chips. Stop adding ice chips when temperature of system has fallen significantly, when temperature of system has fallen significantly, within brackets, about 5 degrees Celsius, about 5 degrees Celsius, about 5 degrees Celsius, right? Then next point, take the final temperature, within brackets, minimum temperature, take the final temperature within brackets, minimum temperature of water, and record it, Next point, measure the final mass of system, final temperature within brackets theta 2, final temperature within brackets theta 2, right? Within brackets theta 2. Then next one, measure the final mass of system within brackets M3, final mass of system M3, right? Okay, then put a subheading as calculation. Write down according to the theory, right? Put a comma, and start from here, right? Write down. We didn't mention the readings yet, right? Readings down. Readings it's fine. In the description, we have the readings, but I didn't list down. Right? My readings or method right. So below this, list down the readings as well. List down the readings as well. Readings right? List down these readings. And have to add 3 more here, right? Specific heat capacity is right? Then for readings, list down this mass of empty calorimeter with stirrer M1, right? Second one, mass of water, calorimeter with stirrer M2, right? Third one, initial temperature of water, right? Next one, right? Final temperature of water, theta 2, right? And then final mass of system, and then final mass of system M3. Final mass of system M3. Right. Next, specific heat capacity of water CW. Specific heat capacity of water CW. Right. Specific heat capacity of water CW. Next one, specific heat capacity of calorimeter CS. Then specific latent heat of fusion of ice. Specific latent heat of fusion of ice. Specific latent heat of fusion of ice. Specific latent heat of fusion of ice L, capital L. Right. Write down below. Write down below. L can be determined. Capital 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 L can be determined using above equation. Can be determined using above equation. Right. Okay. Remarks. This is done. Right. Go to remarks. Remarks. Right. Listen. Now, in this experiment, we are in a decrease in temperature. No? If temperature decreases beyond dew point, right? Again, dew forms. Right? When dew forms, to form dew, some amount of heat is absorbed by dew. Right? So therefore, we are going to have an error. And first thing is you have to make sure that your final temperature is a value greater than dew point. Right? And dew point measure dew point measure plan right? Nigang itani දාන්න බෑ ඉතින් ඒකට dew point එක exceed වුණොත් එළිම මේක dew හැදෙනවා. Right? From the outer surface එකේ dew හැදෙනවා. Right? First point, write down. First point. Final temperature of system. Final temperature of system should be greater than should be greater than dew point. Right? Within brackets. Otherwise dew forms and calorimeter absorbs some heat from dew. Which is not included in calculation. Right? For the same point, brackets same point check dew point before starting the experiment. Right. Next point. Heat loss to environment. Next point. Heat loss to environment. By conduction, convection, and radiation. By conduction, convection, and radiation. Right? should be minimized, should be minimized, should be minimized as discussed before. As discussed before කියලා කියන්නේ reference එකක් ඕන නම් දාගන්න. මම ඔක discuss කරේ in experiment 2. අද කරපු 2 එකේ. හරිනේ? එතකොට radiation එක නැති කරන්න මොකද්ද කරන්න කියලා කිව්වා නැති කරන්න නෙවෙයි. To minimize radiation, what's the precaution? To minimize convection, conduction කිව්වනේ. අන්න ඒ ටිකම තමයි. Right? Next point. Heat compensation method. Heat compensation method. Heat compensation method is used for more accurate value for L by minimizing for more accurate value for L by minimizing the error caused due to heat transfer with environment. Error caused due to heat transfer with environment. Right? Next point. Next point. Only small ice chips. Only small ice chips are used to ensure melting ice is added. To calorimeter. To ensure melting ice is added to calorimeter. Right? Within brackets, write down. Ice cubes are not added. Since it's difficult to control final temperature. And ice powder කියලා කියන්නේ very small chips are not added because it suddenly melts even before adding. Right? Next point. Ice chips should be wiped with filter papers. Wiped with filter papers to remove all water from ice. And only dry ice chips are added to the calorimeter. Right. Next point. A net stirrer is used. A net stirrer is used to prevent ice chips floating at the surface of water. To prevent ice chips floating at the surface of water. Right? Okay. That's it. Let's see what's here. It is advisable to determine the dew point AQ1 approximately before mixing ice. Then by preventing the final temperature of mixture going below the dew point, the error caused by dew depositing on the calorimeter surface can be minimized. Right? When the temperature of the calorimeter begins to fall below room temperature, with the mixing of ice, it begins to gain heat from surroundings. This can be minimized by lagging the calorimeter with heat absorbing materials. ඒක තමයි මේක lagging කියලා කියන්නේ මේකට. Covering. Lagging means covering. Right? අපි heat conduction වල කතා කරන්නේ. Lagging systems. Right? Then OS compensation method used in the method of mixtures can be used. Right? ඒකත් කියවනේ. Heat of the calorimeter. Right. Okay. Right. Any questions? Any questions? Any questions from these two? Right? මම කලින් කිව්ව point එක තමයි when comes to thermal experiments method is kind of simple, but the background is not that simple. It is kind of comprehensive. Background එක තමයි ගොඩක් ඒතකොට දැනගෙන ඉන්න ඕනේ. Right? ඒ හින්දා ඒකෙන් හොඳටම ප්‍රශ්න අහනවා. Right? Background is comprehensive. Background එකේ ඔය එක එක reasons ඔක්කොම ටික දැනගෙන ඉන්න. All good? Right? Online? So are the ice chips added? Are they added one by one or as a bulk? I already told you. One by one. Any other questions? Any other questions? All good? Yeah. More. Calorimeter දැන් මෙහෙම වෙන්නේ dew form වෙනවා කියලා කියන්නේ gas particles liquid වෙන්න ඕනේ. මොකද්ද? absorption එකද liberation එකද? absorption එකනේ. Right? absorption නෙමෙයි liberation එකනේ. Then absorbed by calorimeter. Right? liberate කරන්නේ dew particles ඒක absorb වෙනවා ඒතර calorimeter. Right? What else? හරනේ ඒක confuse වුණා නම් right when dew forms right ඒ point එක confuse වුණා නම් when dew forms dew form වෙනවා කියලා කියන්නේ right dew form වෙනවා කියලා කියන්නේ water is coming from gaseous state to liquid state right gaseous to liquid නෙන්නේ gaseous to liquid වෙනවා කියලා කියන්නේ heat is released right හරනේ මේක gaseous to liquid නේ then this is emitting heat releasing heat liberating මේ පැත්ත liberation එක. When there is a liberation, calorimeter is going to absorb that heat. Right? ඒක තමයි මම දුන්න point එක. හරිනේ? ඒතර calorimeter එක absorb කරනවා dew වලින් liberate වෙච්ච heat එක. ඒ කියන්නේ dew වලින් අපිට ඕන නැති heat එකක් liberate වෙනවා. ඒ අපිට ඕන නැති heat එකක් කියලා කියන්නේ that heat is not included in our calculation. That's the thing. dew වලින් ආපු heat එක calculation එකට දාගන්න දෙයක් නැහැ. Right? All good. Set me the inna. Right. හරිද? හරිද මේක කන්ෆියුස් වුණා නම් ලියා ගන්න. That's a good question. Right? dew form වෙනවා. හරිනේ? මේක තේරෙන්නේ නැතිනේ. dew form වෙනවා. Forming dew means water vapor liberates heat. Right? That heat is absorbed by calorimeter. හරිනේ? ඔයගොල්ලෝ හරිනේ? Okay then. Practical 5.